In Chapter 15, we continue our study of three-dimensional solids. The first one that we're going to discuss is a cylinder. So in Chapter 14, we really discussed when we had the bases being polygons, and now in Chapter 15, we may not necessarily have that condition. In particular, in these first two sections, we're going to look at solids that we make when we have circles as bases. Okay, so a cylinder just is a three-dimensional object where the bases are both circles. Okay, now we talk about the line connecting the centers of the circle, so here would be a center and here would be a center. We talk about that line connecting the two centers of a circle as the axis of the cylinder. Okay, and then if the axis meets the centers at right angles, meaning that if this is a right angle here, then we actually say that the cylinder is a right cylinder. Otherwise, we could have a cylinder, it could be kind of oblique looking, like we had the oblique prisms, but in this, typically when we do these calculations, at least in this course, we're going to assume that the cylinders are right. And then I'm not going to go through the derivation of the different mathematical quantities we can compute using, or compute for a cylinder, but volume is pi r squared h, lateral area is 2 pi r h, and then surface area. Surface area again is that lateral area plus the area of the two bases. So again, I'm not going to go through the derivation, but I can at least kind of discuss the idea. So for volume, again, it's that idea that we talked about before with a prism. When we take the area of the base and we look at a cross section in the solid. So a cross section is essentially what kind of shape do we get when we intersect a plane that is parallel to the bases through the cylinder. And so in this case, we'd get another circle whose area is pi r squared. But now I need to take infinitely many cross sections that extend the height of the cylinder from base to base, and so that's why we have that third dimension in there, which is the height quantity. So volume is pi r squared h. Now lateral area is the area of the sides, right? The area of the sides. But, well, we don't really have a side, but if I were to cut along one of these sides that I see here and unroll it, I'd actually get a rectangle whose dimensions are h by 2 pi r, and so then the lateral area is just 2 pi r h. Okay, surface area, I also have to incorporate the area of the bases, so that's an additional 2 pi r squared. Okay, so some quick examples. So I know that the lateral surface area of a cylinder C is the sum of the areas of its bases. Oh wait, yeah, so let's write that statement out. So lateral surface area, I know that is 2 pi r 2 pi r h. Okay, is the sum of the areas of its bases. Well, its base is pi r squared, and if it's the sum of the areas, both of them are going to have this, so it'd be 2 pi r h. Oh, okay, so I can go ahead and simplify this. Now I don't want to divide by a variable because it's bad to do that, because we may introduce an extra, or we may lose a particular value of that variable. So I can cancel out the 2 pi's, I can cancel out the constants, so I'm left with moving all this on one side. I get 0 is equal to r squared minus rh. Factor that out. R times r minus h, and so either I get that the radius is 0, which if that was the case, then I wouldn't have a cylinder. So I either get r is equal to 0, or I get r is equal to h from this one. Okay, this one can't happen. So the question is, what is the ratio of the radius to the height? Oh, well, that's actually answered for us right here. So it's a 1-to-1 ratio, because they're the same. Okay, and now in example 2, it says that a cylinder is inscribed in a square prism, so that the base of the circle is tangent to each of the sides of this base of the base square. So now I have to use the information given. So AB is 4 and AE is 8, and it says find the volume of the cylinder. Well, this 4 is actually the diameter of the circle, right? So this means that the radius is equal to 2. And so then in my volume formula, volume is pi r squared h. Volume is pi, radius is now 2 squared, and h is 8. So doing the math out, I get 32 pi. Okay, so this section, really, it's all about using the ideas of a circle compounded with the prisms that we've already studied. You may even see pyramids in here too. But again, kind of go back and make sure you understand, especially where this lateral area equation comes from, which kind of the outline is sketched here, and that is kind of the basic ideas of cylinders.